Hi everyone, today's lesson is on surface area, Unit 5, Day 6. When we talk about surface area, we're talking about the total area of all of the faces of a 3D figure. When we talk about lateral surface area, we're talking about surface area except for the area of the bases. Okay, so we have a lot of equations, but luckily we don't have to memorize these equations, all right? You will always have access to an equation sheet, and there's a poster in our classroom that will have the equations as well. What we need to focus on is using the correct equation and entering the correct values so that we can find the surface area. Now, there are a number of types of figures that we have surface area equations for, including prisms, cylinders, pyramids, cones, and spheres. When we talk about a prism, right, we remember that we name all of our prisms based on the shape of the base, right? So if our base here is a rectangle and this here is a rectangle, we name it a rectangular prism. By comparison, if we had maybe a triangle like that, then this would be a triangular prism, right? Where this triangle and that triangle would be our bases, and then this value here would be our height, okay? When we find the total surface area, we're going to find the perimeter of the base. So the perimeter of our base, adding up all of those sides, multiplied by the height of your 3D figure. Now this is very important. The height of your 3D figure is also going to be the side length that connects your two bases. So if you know you have a base here and here, you'll see that this height connects, right? Is a length between those two bases. Plus 2 times b. B is the area of your base, right? You need another equation to find the area of whatever that figure is, right? So if it's a rectangle, it'll be base times height. If it's a triangle, it'll be 1/2 base times height. Okay? When we talk about a cylinder, the total surface area is going to be 2 pi RH plus 2 pi r squared. And all you need to know is the radius, which is from the center going to the outer point of the circle, and the height of your 3D object, right? So similarly, this height also represents the length between our two circular bases, right? And we talked about how a cylinder is essentially a circle prism. It just has a fancy name. When we talk about a pyramid, we're going to use the equation 1/2 PL plus B, where P represents the perimeter of our base. So again, we're going to be adding up the sides of the base times L, which represents the slant height. Now the slant height is going across the face of one of the, faces of our pyramid, right? So you can imagine that there is the height that goes through the center of the pyramid, and your slant height goes across the outside edge, okay? So we will use 1/2 times the perimeter times the slant height plus B, which is the area of the base. So if it is a square, then we're doing base times height. If it is a triangle, we're doing 1/2 base times height, so on and so forth. Now for a cone, we're going to use the equation pi RL plus pi r squared, right? Where r is our radius and L is our slant height. So similarly, we're going outside, right? That's your slant height. And then the one that's going straight up and down is our height. Okay. And then lastly, we have a sphere. In order to find the surface area of a sphere, we can use 4 pi r squared, where r represents our radius. If a question asks for surface area or total surface area, we'll use our total surface area equations. If it asks for lateral surface area, we use the lateral surface area equations. If it just asks for surface area, we always refer to total surface area. Okay, so if it doesn't specify, you find the total surface area. Okay, our first teacher example asks us to calculate the surface area of this given 3D shape. So the first thing we need to do is identify what is this shape. And what I can see here is I have a triangular base here and a triangular base here. I have two bases. The bases are triangles. I know that this is a triangular prism. And in order to find the surface area of a triangular prism, we're going to use our equation PH plus 2B. So we know that my base is a triangle, so I need to find the perimeter of a triangle. I know that this side is 7, this side is 7, and the bottom is 4. So the perimeter of my triangle is going to be 7 plus 7 plus 4, which will equal 18. My height is the height of my 3D figure, right? It's connecting my two bases. In this case here, my height is going to be 12, all right? And because of the orientation of this, it's a little bit hard to identify that 12 as a height. However, if we imagine it's kind of standing up where the triangle is kind of on the ground, and then we have something that looks more like this, where this is kind of flat, then it's easier to tell that this height would be 12. Okay? And then lastly, we need to find the area of our base. So we know that the base is a triangle, so we need to use our equation 1/2 base times height, and we're only finding the area of this triangle. So this side is 4, 7, 7 with a height of 6. So here, our 4 is going to be the base, our 6 is our height because those are our perpendicular sides, right? So 1/2 times 4 times 6 gives us 24. Now that we have all of the values of the variables, we're going to plug it in. Perimeter is 18 times the height is 12 plus 2 times 24, which is our base, giving us a total of 240 centimeters squared. Go ahead and try teacher example number 1 on your own. Teacher example number 2 asks us to calculate the total surface area of this given 3D shape. So here again, I can see that I have a square, 5, 5, 5, 5, and then my slant height here is going to be 8. So I know that this is a square pyramid, because I have one base and it comes up to a singular point. So our surface area equation for a pyramid is 1/2 perimeter times the slant height plus the area of our base. So in order to find the perimeter, I'm going to add up 5 plus 5 plus 5 plus 5, which gives me 20. My slant height is 8, and B, I need to find the area of the base. The base is a square, so I'm just going to do base times height, which in this case is 5 times 5, or 25. So now again, I have all of the values that I'm looking for. 1/2 times 20 times 8 plus 25. When I put that through the calculator, I end up with 105 centimeters squared. Try student example number 2 on your own. Okay. And when you're done, make sure and do your reflection.